So good morning, friends. Once again, I welcome you all for today's session, a practical session on the Weka. So to start with, first we'll see some of the glimpses of the Weka tool. So Weka is basically a machine learning tool which is used for the data mining purpose to extract the useful information from the data that you have. So Weka is basically, it was developed and designed at the Weka University in New Zealand. So why the name Weka is given? So Weka is the only bird found in the New Zealand. So it's a national bird of the New Zealand, and that's the reason they have given the name to this tool as the Weka. So if you see in the figure, in the GUI of this tool, you can see that bird's image is shown. Well, so what Weka offers? So Weka offers you with the thousands of classification algorithms, more than 75 data processing algorithms. You can have more than 50 filtering algorithms. You can have more than 25 unsupervised classification algorithms like k-means clustering. You can have association rule mining and so on. So it also offers you the different algorithms to select the attributes or to select the features in our case, because since the beginning of this course we talked about the features, right? And we know what is the feature. Features are nothing but the attributes of your data set. And so far we have seen two algorithms to extract the best subset of features from your input instance space. Well, so you can have those algorithms as a part of this Weka tool, like principal component analysis and the subset selection methods, like wrapper method and a filter feature selection method. So you will get all the algorithms as a part of feature selection. So Weka is on and all, it's a complete package for data mining. Okay, so it's basically a machine learning tool which is used for the purpose of data mining or to extract the information from your data set. So where do I get this tool? So you can just Google it. You can just type Weka 3.9 is the latest version, if I'm not wrong. So maybe in last couple of days it may change to 3.10, but the last version on which I have worked, it was 3.9. So you just Google it. You can just type in Weka and you will navigate it to the site called as wakaito.github.io, where you will get the different versions of the Weka software. So you can have stable version, you can have developers version, and you can have beta version. So it's always better to download the stable version of Weka because for the beginners and for the education purpose, the stable version is recommended. Well, just download this extractor or the Windows extractor or a Windows exe file from the website I have just mentioned, and just run it as usual that you install the other softwares. So its installation is very easy. But before that, before you install Weka, please ensure that the Java is installed on your machine, JRE and JVM, with the at least this 3.9 Weka version. It supports the lower version of Java to be 1.4. So I know that today's machine, they are equipped with the higher version like 1 or 2.1 or 1.9 onwards. So at least your machine should be installed with 1.5, 1.4 JRE and JVM onwards. So apart from this, it is ideally good practice to install one more software in order to support the Weka. If you want to use the advanced feature of Weka, then Install one more software called as WinPicap. So it ensures that automatically you will get the updates of the newer packages and the tools that will be implemented. Okay, so that's all from the introductory part of Weka. And please let me know that whether the Weka's GUI chooser, this tool is visible to all of you. Anyone can type in the chat box.
Yes,
okay,
sir.
fine. So when you, after installation, when you open the Weka, you will find this window, and on the right of the screen, you will find these are the different applications of Weka. What do it mean? So it means that you can have different option to work in Weka. So Explorer is one application, Experimenter, Knowledge Flow, Workbench, and Simple CLI. So Workbench is the new application added in the Weka tool. If you go through the earlier versions of Weka, you don't find this option, but this is the new update in the latest Weka version. So what are these applications? So these applications are used for the specific purpose. So Explorer means what? Explorer is basically the GUI visualization of the entire Weka tool. So Explorer will provide you the graphical user interface. So I know that majority of students or majority of learners in the beginning they would like to work in graphical user interface environment. So Explorer will give you the GUI environment. Then the next application, that is Experimenter. So Experimenter is again, it is specifically used to test the performance of multiple classifier. Right now, this ability is not given in the Explorer application. So particularly when you want, you have multiple classifiers and you want to know or you want to test or evaluate which classifier gives me the best performance. So for this kind of task, Experimenter application is the right choice. Then comes the Knowledge Flow. So Knowledge Flow is one of the widely used application in the Weka. Why? The reason is that here we are creating, using Knowledge Flow application, we are creating the graphical visualization of your machine learning model. Right, right from selecting the data set, then pre-processing the data set, and then applying the machine learning model, building the model, and then looking at the results of the model. Right, so everything will be created in the graphical manner. So it's a complete visualization of the entire process of machine learning. Okay, so knowledge flow, we also see what is knowledge flow. So as a part of this today's session, I hope that because this is a big tool, so I will try to complete the first application, that is Explorer. And Experimenter is very easy, hardly it will need 10 minutes or 10 or 20, 15 minutes to explain. But knowledge flow and simple CLI, okay, we have talked about the knowledge flow. Then I will go to the next application. I will give you the brief of this application, simple CLI. So simple CLI, it stands for simple command line interface. So whatever you do in Explorer, it's actually GUI, but still there are few learners or few users, particularly those who loves to work in open source operating systems like Linux and so on. The different versions or the flavors of the Linux, So for those users, command line interpreter is the best application to use the Weka. So Weka has also the command line interface. So those who are love to work on the command line interface, so Weka has given the platform of command line interface. And then finally comes this Workbench. So Workbench, as I told you, that this is newly added application in the Weka. So Workbench is provided. Workbench is basically it is a complete environment for the user. For example, in Explorer, I can just build the classifier and I can test the performance of that classifier. But if I want to test the performance of a multiple classifier, I have to use the Experimenter tab. So in that case, Or sometimes you may want to create the complete visualization of your machine learning model, right from selecting the data set, then splitting it into train and test data set, applying the machine learning model, building the classifier, and so on, right? So if you want to do all these things at a single platform, then Workbench is the right application for you, or Workbench is the right, I mean to say, platform to work if you want to work with the different tasks of your machine learning, right? Like testing multiple classifier, evaluating them, building them, creating the model, and so on, right? So Workbench is actually a single interface for all of these things. So when you are working in Workbench, then you don't need to switch from Explorer to Experimenter in order to test the multiple classifiers performance. Well, you don't need to switch from Explorer to knowledge flow in order to create the picture or the visualization of your machine learning model. Okay, so Workbench in all, or if we sum up Workbench, then it is a single interface for multiple tasks. Well, that's it. So today we'll start with the Explorer, and we will try to get our hands dirty with preparing the accessing the data set and preparing the data for building the classifier or for building the machine learning model. Okay, so I'll click on Explorer and the new window will be opened. So you just give me a moment to share this new window after clicking the Explorer. Okay, now my new window is visible to all, because when I click on Explorer, a new window will be open, which actually gives me the graphical user interface for the Explorer application. This new window is visible to all? Is it visible to all?
Sir.
Actually, I have shared it. Okay, just give me a moment. I will share a new window. Okay, is it visible now? The screen is getting shared. Just wait for a second. Okay.
Yes, sir.
Yes, sir.
So this is the graphical user interface that we can access through the Explorer application of Weka. So before we start the Explorer application, let me give you some more information. These applications may be Explorer, Experimenter, Knowledge Flow, Workbench, or Simple CLI. They have been implemented as a class. Okay, so they are also referred as the different classes of Weka. So Explorer is one class of Weka, and in order to understand, to make it very simple to understand, we just call it application. Okay. Okay. Now this is the GUI, and you can see that at the top of the screen where I'm moving my mouse, these are the different tabs available. So the first tab is the pre-process tab, and unless and until you select the data set, the other tabs won't get enabled. So before I select the data set, then these tabs, they are disabled. You can find it, right? So what this means? This means that we have to import the data set in order to perform some operations on that data set. So from where I do access the data sets? So Weka, it provides the default data sets. There are around 14 to 16 data sets, the default data set that Weka provides you. And we'll try to import one of these data sets. So this, when you install Weka, by default, these data sets, they are stored in your program files folder. This program files folder, inside it, the new folder with the name Weka will be created, and you can find it here. This, I think only screen is visible. This new window is visible to you?
Yes, sir.
Yes, sir.
Okay. Okay, good, good. So now here you can find out there are different in this data folder, the different default data sets are available. So there are around more than I would say more than 20 overall 20 data sets are available. So out of this data set, I'll just select this data set with the name weather.nominal.arff. Now, can anybody please tell me the abbreviation of .arff? Any guess? No? Okay. Because you are experiencing this tool first time, so I hope nobody knows it. So .arff, it stands for Attribute Relation File Format. And this file format is very simple in Weka. Now, does this mean that the Weka only accepts the .arff datasets? No. Weka has the ability to pre-process the different types of dataset, may it be .excel format, .csv format, may it be your MySQL files or anything else, right? So you can import the different types of datasets particularly in Weka. So for time being, I will select this dataset called weather.nominal.arff, and you can find some magic here, right? So this data set we have imported in Weka, and first we'll see what are the different information that we can explore from this data set. So here the relation means the name of data set. So the name of data set is weather.symbolic. How many instances, how many samples are there in this data set? There are 14 samples in this data set. Whereas the attributes, what it means, features, the number of features or the number of columns in these data sets are 5. Okay. Now these attributes, they have been shown here. The outlook, the temperature, humidity, windy, and play. So these are the 5 different attributes or the features of this data set called weather. Well, now when I click on Outlook, if you look at or if you pinpoint to this window, you will find that this attribute, it contains 3 different values. That means the Outlook feature will either have the value of sunny, overcast, and rainy. Okay, these 3 values. Well, then similarly, temperature, this attribute will have the different, it contains 3 different values. The temperature, it may be hot, it may be mild, or it may be cool. Okay. Then humidity has 2 values. This feature will have 2 values, that is high, humidity is high, and humidity is normal. And then the windy, then it's true, it has two values, true and false. And finally, the last attribute or the last feature or the last column of this data set is play, and this play feature or this last attribute has only 2 values, yes and no. And this last attribute is typically called as the output class label. So remember, by default in Weka, the last attribute is nothing but your class value. Okay, the output class label. So my output class is whether to play or not, and it contains 2 values, that is yes and no. Okay, so what this 9 count says, there are 9 such instances in the data set out of 14 which has the class label yes. There are 5 such instances or samples in this 14 instances or in this data set which contains the output class label no. Okay, so these values actually typically they are used to decide the value of play. Okay, and what is this square at this window or at this bottom of the screen? This colorful boxes, they are basically the histogram. Okay, so the histogram is basically represented for these 2 values of class, that is yes and no. So blue represent yes class. This is the bar, you can call it as bar or the histogram. and this red rectangle or this red bar is basically it represents the no class. And 9 value, what it means? There are 9 such samples which has this output class label to be yes, and there are 5 such samples which contains the output class label no. Well, can I have the histogram for the other attributes as well? Yes, answer is yes. We can have the attributes, or sorry, we can have the histogram for the other attributes as well, for other attributes as well. So we will just select the Outlook and we'll see. So this is the histogram for the Outlook feature. We know that there are out of this 14 instances, there are 5 instances for the Outlook feature which has the Outlook feature value to be sunny. Then there are 4 instances which has the overcast value for the Outlook, and there are 5 instances which has the value rainy for this feature Outlook. Fine. So now in all, what we can see is this first histogram, it says that out of these 14 instances, which has the Outlook value, out of these 14 instances, there are 5 instances which contains the value sunny. Okay, and out of these 5 instances, 2 instances which has the value sunny, its output class label is yes, and there are 3 such instances. This actually represents out of this 5, 2 has the output class label yes, and remaining 3 has the output class label no. Similarly, the second value for the Outlook is overcast. Now there are 4 such instances out of 14 which has this overcast value for the Outlook feature, and all these instances which has this overcast value for the Outlook feature, their output class label is yes. Okay, because it is indicated with blue color. Same is the case for the third value of the Outlook, that is rainy. So out of 5 instances of Outlook feature which contains the value rainy, there are 2 instances which belongs to the output class label no, and there are 3 instances which belongs to the output class label yes. Okay, so I hope this information is enough. Now can I edit the data set in the Weka? Yes, answer is yes. And if you want to edit the data set in your Weka GUI or Explorer GUI, then this is the option. So you can click here and you can see here, this is the data set. This is actually look like same way, but when you open the .arff file, it is actually used in WordPad. So you know, this tabular form you may not see when you open the .arff file in WordPad. Well, so can I edit the instances or the samples in this? Yes, you can edit the values of your instances. So if I want to change the class of the first sample, then I can change it. So it was earlier no, so I change it to yes. But don't make any changes because the dataset will get changed. Then can I edit some attribute values? Yes, I can edit the attribute values as well. I can change the attribute value of sunny. Sorry, this temperature feature. Temperature has 3 values: hot, mild, and cool. I can change the value of the temperature for the second instances. Okay, so it was earlier hot. I can make it cool, mild. So let's change it, and so on. You can change the any instance value, or you can edit and drop. Oh, sorry, you can edit and add some more instances as well. So if you want to add the 15th instance or the 15th sample, then click here. So this will add the new instance in this table which has this value. Okay, this is the default value when you add the instance, right? So you can just make undo if you want to, if you don't want to save the changes. So I will just make it undo, so that instance is removed from the data set. So just click on OK. We have now not done anything. So if you want to save, you have to click on OK. So that's it from the pre-processing part. Now I know that most of you, they are eagerly waiting to work with the classifiers. So let's see what are the different classifiers that that are available in the Weka. So this classified tab will give you more number of classes to choose. Okay, so you can have different classifiers or classification algorithms in Weka. So you can have base algorithm classification algorithm, you can have function classification algorithm, lazy classification algorithm, meta classification algorithm, miscellaneous algorithms, right? Those who does not belong to any family like lazy, functions and base, those algorithms, they are kept into this miscellaneous algorithms. Then rules algorithms, and finally you can have tree algorithms. Okay, so I will try to select any one of this algorithm tree. Okay, before I select any algorithm, classification algorithm, so I feel that it is important to know you that we can also see what type of value each feature holds. That is very important from our perspective. So if I take the Outlook feature, then Outlook, the values, the attribute values of Outlook feature or the feature values of the Outlook feature are nominal. That is shown here. Okay. Similarly, the second feature has also nominal values. The third feature also has the nominal values, and so as the windy also has the nominal value, whereas the last attribute or the last output class label column play should also contain the nominal value. Now, do our data set has only nominal values? No. Our data, it is not, we cannot guarantee that all the time our data set contains the feature values to be nominal. Sometimes some of the features, they have numeric value, some feature they may have nominal values, some feature they may have discrete values, and so on, right? So I'll import one of the data set just to show you that your data set may have numeric value. So I'll just go back and see, this is the weather.numeric data set which contains the numeric values. Okay, so here you can see this data set weather.numeric also contains 14 instances and 5 attributes. The first attribute or the feature has the nominal value. The second attribute, that is temperature, now it contains numeric value, and because it contains the numeric value, we have to represent these values, temperature feature values, with some statistics. So what is the statistics? Because we have 14 instances, so all the 14 instances will have the value for the temperature feature. That means we have 14 different temperature values. So we're supposed to find out what is the minimum value in the 14 instances. So the minimum value in all the 14 instances is 64. What is the maximum value? So maximum value amongst all the 14 instances is 85. So now this minimum and maximum, it shows me that the temperature feature has the range of values, okay, which range from 64 to 85. And whenever there is range of values to your feature, then it is ideally good practice to take a mean of that column, or to take the mean of all the feature values, and also calculate the standard deviation. I have already told you how to calculate the mean and standard deviation in the first unit. Okay, so use those formulas and you can find out the mean and standard deviation for all the 14 instances. So 73.57 is the mean of this column temperature, and 6.57 is the standard deviation. I can show you. So this is the values. So these two columns, humidity and temperature, they contains the numeric value. So the mean of this second column is 73 and its standard deviation is 6.572. Okay, so that is one thing that I want to show. Well, now we'll select one more, I mean to say, one more data set. Now this time I will select the glass.arff, and you can see that this glass.arff, this data set, it has total 214 instances. It has 10 attributes. These are the attributes, and the last attribute, as I mentioned, it is always a output class label. So now here for this glass data set, the output class labels have 7 different values, right? That means we have 7 output class labels. So this is a multi-class classification problem, remember. And the weather.nominal data set, which actually comes in binary classification problem, because the last output, the last column has 2 labels, that is whether to play yes or no. Okay, so yes and no. So that means we have yes class and no class. And we know that when there are only 2 classes for the classification, then that problems are the binary classification problem. So here there are multiple class labels, more than 2. So this is a multi-class classification problem. So what is this RI? So you need to basically have some knowledge on the data set. So this data set is basically represents what are the different types of glasses that we want to classify. So what are the different types of glasses? So there are some glasses which holds the containers, which are tableware, which are headlamps of your vehicles. Some are wake wind non-float, some are wind float, some are build wind non-float, and some are build wind float. So these are 7 different types of glass that is being manufactured. Okay, and what are the attributes of the glass? The glass has 9 different attributes, excluding this last one. So the first attribute is basically the refractive index. So you need to have some knowledge of physics. You might have studied about the refractive index. Then for the remaining features, you need a knowledge of chemistry. So the second feature, it is the sodium. Third is the magnesium. Fourth is aluminium. Fifth is silicon. Sixth is potassium. Seventh is I just forgot it. What is it?
Calcium.
Calcium, right? And eighth one is the barium, and ninth one this Fe. I think that's iron. Right? So these are right. So these are the attributes, and we you can observe that each of these 1 to 9 attributes, these features, they holds the numeric value. So we know that whenever the feature has the numeric value, then we have the statistics like this: minimum, maximum, mean, standard deviation, F1 score, then normalization. So as we move ahead, I will tell you what is normalization, how do we perform the normalization on the data set as well. Okay, so this is what the preliminary information, and this is the histogram for each of this feature. So if you want to visualize the histogram for all the attributes at a glance, then just click here. So it will show you the histogram for all the attributes or for all the features. Okay, now it's time that I know that every one of you is very eager to know the classifier, to build the classifier. So now here I will go in classify tab, and I will select the classifier from this. So I want to build a decision tree classifier for this problem. So the decision tree classifier that I will select will be J48, because J48 is a widely used classifier. Rest of the things I will keep it as it is, because next time I will show you what is this using trained data set, supplied data set, and so on. These options we will discuss later on. And just click on the start, and your job is done. So you have built a classifier, J48 classifier for the glass.arff dataset. And here in this window, you can see you can interpret the output. So the relation name is Weka.classifiers.tree. So classifier.tree is our classifier, and the name of this tree classifier is J48. Relation name, that is the name of dataset, is glass. Total number of instances in this dataset is 214, and total number of attributes are 10, which ranges from Ri to 7 types of glass. And test mode is, so we have kept it on cross validation mode, 10-fold k-fold cross validation, and the value of k that we have selected here is 10. We know that the value of k is, the standard value of k is 10. Okay, so we kept it as it is. And then this is basically J48 prune tree, and this is basically the representation of your decision tree, but I will tell you later on the visualization of this text tree. Okay, so this tree, it has 30 leaves and it has 59. The size of the tree is 59, whereas it has 30 number of leaves. Okay, and this is some other kappa statistics. So we want to basically interested to know the accuracy. So out of 214 instances, our J48 decision tree classifier has correctly classified 143 instances. That means the accuracy of this model is 66.82%. So it is pretty good, or it is average. The accuracy is average, not too good and not too bad. So it's ranges in the good and bad, between the good and bad. And the error rate, we know that because 71 instances are incorrectly classified by the J48 tree, so the error rate is 33.17. And this is basically, you can call it as a detailed accuracy by the class. So this is true positive rate for each of the class. Then this is false positive rate. This is precision, and this is recall. This is F1 measure. So we have seen how to calculate the F1 score. We have just seen the F1 score. Remember, my friends, there are versions of F1 score. You can calculate F2 score, F3 score, F4 score, and so on. So if you want to see more on the F1 score, you just subscribe to the video channel of the Ian Bitten, who will give you the more information on the F1 score. Then MCC values, then ROC. ROC is one of the important value of the accuracy. Okay, when you are evaluating your classifier. So what is ROC? ROC it stands for receiver's operating characteristics. So I will also talk on it later. I will make a separate video on ROC, don't worry. And then PRC, and then class, precision receiver's characteristics, and so on. And then this is class. So these are the 7 class, and these are the different rates. And finally, you can have the confusion matrix here, which we have just seen, which gives you which allows you to perform the evaluation of your classifier. So this is the diagonal, and we know that diagonal, it represents the correct classification. So anything except this diagonal, so upper triangle of this diagonal and the lower triangle of this diagonal, they represents the false negative values and the false positive values. So that is what. Now what I will do is, because I have got this 66.82% accuracy, now I can see what are the different parameters that I can change from this classifier. So if you want to see the different parameters or the arguments that are being used using this tree, then just simply click here, and the new window will be open. This new window is visible to you all? Is it visible?
Yes, sir.
Okay, I will go fast because we are running behind time. So See, the tree that we have just seen, this is prune tree, and unpruning is kept false, right? So what I will do, I will make this decision tree J48 as unpruned tree. So I will make it true, and I will click on save and then okay, fine. And now again I will click on start, and now I will see what is the accuracy I will get. Yeah, okay. If I unprune this J48 tree, then I will get the accuracy improved. Okay, my accuracy is enhanced. Earlier, for this run, we got the accuracy to be 66.82, but for this, after unpruning the tree, my accuracy is improved, and now it is 67.28. Okay. Am I audible now? Am I audible?
Yes, sir.
Okay, okay. See, we are running out of time, so for time being, I will just stop here. Uh, if you are interested, then I will take your class in the evening. Otherwise, we'll meet on tomorrow. No problem. So you can end this meeting. If you have any problem with respect to this Weka, all the videos, they have been uploaded on the YouTube channel. You can subscribe this channel and watch the videos on Weka. So there are around 7 to 8 videos I have already uploaded on Weka. Thank you for patiently listening. See you on tomorrow's session. You can end this meeting now.